So hi everyone, I'm Kevin Griffin. Welcome to the HamptonRoads.net users group. I'm joined by my partner in crime, Drew Carpenter, who is actually I have no idea how the video is oriented. So he's to my right on the video, and then the person below me is Sean Killeen. How are you today, Sean?
Doing great. Happy to be here. Thanks for having me.
Yeah, we're glad to have you back. I think last time you were with us, it was pre-COVID, right? It was like
I
right
think so.
before.
And I'm trying to remember if I was at the user group or if I was on your Twitch stream at that time with SwiftKick. I'm not
Yeah.
sure.
Oh yeah, I forgot about that. I think that was a while back.
It could have been a while back. Either way, it's good to see you now again anytime.
Yes, sir. It's so it's been fun. We've been keeping this up through all these hard times. Thank you to everyone out there that's watching. And so, Sean, you're going to talk to us today about SpecFlow and testing, which I think I specifically asked for because no one talks about testing enough, in my opinion. And I just kind of enjoy sessions about testing. So this is more just personally for me. Everyone else just
I'm
gets
happy
the
to hear
benefit.
it. Anytime someone's willing to talk about testing is Drew knows this from experience as well. Like, I could talk about testing forever. I love it. I think it's incredibly crucial. And the thing I'm excited about with this presentation is I think we're going to talk a little bit, hopefully, about some of the collaborative nature of what we can do with testing. I think a lot of times we think about testing in a certain mindset, and I think that when we explore tools like SpecFlow and the techniques that they enable, I think we can get a little bit better at collaborating with our end users and being clearer for ourselves and our stakeholders. So I'm excited to dive into it.
Well, good times. So folks out there in chat, if you have questions along the way, drop them in chat. I know Sean's going to keep an eye on it, but if there's a logical stop, I'll jump in and ask the question on your behalf. But Sean,
I welcome illogical stops as well.
Okay, sounds good. So Sean, you just want to take over and kick us off?
Let's go for it. All right, great. I'm going to go ahead and share my screen here. All right, and Kev, if you could just confirm that you see that.
Yep, you're good to go.
Excellent. All right. So good evening, everybody. Welcome to the HamptonRoads.net user group. I'm really happy to be here and talk with you this evening. As Kevin said, we're really going to talk about a topic today that I hold near and dear to my heart, which is testing and the collaboration that it enables. I want to start off the talk by saying, first and foremost, I hope you're all doing as well as you possibly can be. As Kevin was mentioning earlier in our pre-show chat, we've rolled over the 1-year mark of quarantines and that fun time. So in the spirit of that, I have my true living background here. This is not a glamorous filter as much as you might want to believe that. This is my actual office space, cluttered desk to my right, couch with some pillows to my left, and we'll be right here. So just know that I'm going through this all with you, and I hope you're all making the best that you can of current times. So what are we going to talk about today? Oh, I guess I should probably talk about where I'm from first. So I'm currently with a company called CapTech Consulting. So I'm out of our Reston office, but we're a national firm with offices. Our headquarters is in Richmond, Virginia, and we've got offices in Charlotte, Atlanta, I think Denver. I'm fairly new there. I joined in October, so I probably should have a better list of those offices handy. I know we're in Philly as well. But excited to be here, and they're a great company. Encourage you to check them out. Really fun consulting company doing a lot of great work in the commercial space, which has been really fun and exciting. Also like to give a shout out before when I start this presentation talking about the .NET Foundation. Normally this is where I would say, hey, show of hands, who's heard of the .NET Foundation? Hopefully since we're on Kevin's stream and a lot of folks here have been in the .NET space for a while, hopefully you've heard of the .NET Foundation at this point. And if you haven't, highly encourage you to check them out. They're an organization, right, sponsored in part by Microsoft, but separate from Microsoft as an entity working to help bolster the efforts of .NET in the open source community and working to establish both, help for projects that need it and systems that can support those projects and the growth of open source and the .NET ecosystem in general. So really recommend you checking those out. Membership is open. You can apply for membership. It's a fairly low bar. There's a small membership fee. I don't mean low bar in that they accept everybody. I mean that you know, if you have some interest in the .NET community and you can show that in any small way, chances are they're going to accept you as a member. We want to build this community. There's a membership fee, but if that's a hardship for you, you can apply to have that waived as well. So highly recommend going ahead and checking them out. They're a really, really great organization that I'm a pretty big fan of. So that's my plug for the .NET Foundation. Myself, I'm Sean. I'm not going to leave this slide up too long. We'll have it at the end as well, but I love talking about this stuff online, offline. So if you ever want to connect with me and you've got a question or a follow-up from this, or you want to take the discussion further, or you have an idea for another presentation or talk that might interest you, you can always reach out to me. I'm on Twitter. I've got a blog. I'm on GitHub. I'm in all the standard places you might find a developer who's not hiding from the public. So feel free to reach out to me there. All right, so let's jump in and do this. Let's talk a little bit about SpecFlow and functional testing and specification by example. So we're going to talk first up about why this matters. What is the problem with testing? What are some of the challenges that we sometimes encounter? And we'll sort of focus this at the requirements level. And that's because we're then going to talk about how we can improve our requirements with a technique called specification by example. From there, we'll talk a little bit about how functional or acceptance testing, some people call it different things. For the purposes of this talk, I'm calling it functional testing. We'll talk about how that fits into the larger ecosystem of specification by example. We'll talk about the Gherkin syntax and how it can formalize your specifications and your examples. Now, and give you a great tool, a great platform to begin to automate some of these tools. And that's where some of these specifications, and that's where we'll get into SpecFlow. SpecFlow is a fantastic tool. Previously had a commercial component to it. Now it's free for everybody. It's a fantastic tool that maps some of these examples to your test automation framework. And we'll dive into SpecFlow. We'll talk about some of the basics. We'll do some live coding and check that out a little bit, and we'll go from there. So as Kevin mentioned, at any point during this talk, feel free to throw questions in the chat. I will keep an eye out. My monitor's kind of over here, so I'll do my best, but Kevin is authorized to interrupt me at any point, and we can break and take questions. All right. So let's jump in. So let's talk a little bit about why functional testing and why the idea of this matters in general. One of my favorite comics from SKCD is, my motto is move fast and break things. And there's a big list of jobs that this person has been fired from. And unfortunately, the credit is cut off here. That should be at the bottom. But there's a long list of jobs because in our profession, we don't have the luxury of moving fast and breaking things, right? We have to move as fast as possible without breaking things, right? And as developers, it's important to us, it's crucial that we keep our feedback loops as small as possible, that we make sure that we're limiting the number of regressions that we have in our software and the amount of problems that we cause, the amount of churn in our development process, right? We want to produce a great stream of value for our stakeholders and our end users. And the more we can do that with less cruft, the better it is for us, the better it is for our stakeholders. And that's kind of where we want to get to. So usually this is we do some show of hands. So if you have a story about this, feel free to drop it in the chat. But in terms of why this matters, sometimes we have confusion over requirements. Now, I'm sure that all your software development projects are probably perfect, and you've never had a requirement that is incorrect or that you misinterpret or that someone later says, "Oh, that's not quite right." Right? So it's very easy for requirements, especially implicit requirements, to cause confusion or for different people to interpret them differently. And so it's important that we keep that in mind as we think about functional testing and a better way to approach this, right? We often have a lot of confusion in our requirements and our discussions about requirements. And so we want to take that into account, and we want to see if we can limit that confusion as much as possible. There's the concept of trust here in several ways. The first concept of trust is for your end user and your stakeholders. If you are producing software that is continually failing, or where a bug fix causes another bug, or you've been in those situations where it becomes pretty clear that there's a quality problem with the code, what starts to happen there? Well, the trust of your end users and your stakeholders, if you're delivering for them, starts to break down, right? When in that absence of trust, what happens is our feedback cycles get longer and longer. We introduce manual regression testing, or we introduce long periods of manual testing, or we introduce the idea of many levels of review, or we have to pause for 3 months to make sure we really harden this application before we ship it. And that feedback loop, as it gets longer and longer, it's much easier for waste to creep into the process. It's much easier for a lack of collaboration to start to show, and that gap to start to become wider. And similarly, we want to trust what's happening in our applications. We want to be able to trust that we can work with a piece of code and it's not going to break. I mean, I don't know who's ever had who's worked with a piece of software before, right? There's always that one piece of code that, said, okay, who wants to modify this code? And everyone's kind of like, not me, right? And they kind of, we all shy away from it. And I'm going to tell a story about how a team that I was a part of actually tackled that story tackled that challenge on a client project. But when you don't have that kind of feedback loop in place, or that kind of mechanism for moving forward, that lack of trust can start to become wider and wider and wider, and leads to a breakdown of your overall delivery cycle. This term is a term that I don't know if I've coined it or not. I'm the first person I know of that said it, but I call it feature fighting. And that is when feature A has been completed and you complete feature Z down the road, and you realize that feature A is broken. And that is because the stakeholder responsible for feature Z has asked you to implement the opposite of what feature A is. And so now you have two different stakeholders that maybe have different understandings of how the application should work. And it becomes very difficult to understand, well, why did feature A break, right? Where does that happen, right? So you kind of have to go back through your conversations, look at requirements. Hopefully you've got some sort of system for documenting this in place. And so I call it feature fighting, where you may have different stakeholders disagreeing, or your application may be disagreeing at the feature level about what should be happening. All right. Next up, in terms of the challenges that we have, I don't know if anybody's dealt with this on a project, right? But the idea of, when is a story or a piece of functionality complete, right? When is it, if you've ever gotten to, if you're using some sort of maybe a Kanban style workflow, and you get to a sort of a user acceptance period, and then they kind of say, oh, well, the stuff that you listed works fine, but what about X, Y, and Z? And X, Y, and Z was never a part in your understanding of the original requirement. Right. So when are we done? Right. I've often, used the phrase that, it's not a bug if I submit it to my contractor and I say, well, yes, the yard looks great, but there's not a pool in it, and I wanted a pool in it. But it wasn't a part of the original project plan or requirement, right? So what happens when we maybe have some friction around the idea of what done looks like, right? What happens is we get that churn introduced back into the development lifecycle, where we're going from the acceptance part of a story, right? And now more information is coming back. It's got to jump back to the developers, or we have to kind of go back to the drawing board, have more conversations about what this should be. And more often than not, what we also have, and this is no fault of stakeholders if they're the ones sort of doing some testing and sign off, what will happen sometimes is stakeholders will say they're going to test a certain piece of functionality or a certain feature or a certain user story, and they'll do a little bit of exploratory testing, which is, by the way, great. I love when users do exploratory testing. I think what happens, though, sometimes is you'll get reports of suggestions or feedback, and feedback, by the way, is great. But someone might say, hey, I can't sign off on feature A because feature B, which is over on the other side of the application, has a strange thing going on with it. Right. And that can be difficult to have that conversation around, how do we compartmentalize our testing efforts? Right. So this is, and how do we, understand the automation and the steps involved with that? So this is the idea of, we want to kind of get to a more common place around what is the understanding of done, and how do we communicate about that as early as possible in the process. Right. So enter automated testing. Right. Automated testing, and this kind of testing in particular, this is our safety net. Right. Our safety net is, every test that you write, every automated test that you write and invest in, is like another strand in your safety harness. Right. When we have enough strands in your safety harness, what does that let you do? Well, it lets you move confidently. Right. We talked about moving fast and not breaking things. Right. Every bit of investment that you make in your testing automation and your automated testing should enable your team to move faster with more confidence, to close those feedback loops, to be less afraid to change and adapt your software to evolving requirements, because you understand what the software is doing and you understand how to verify that software, both from a developer's perspective of this is the thing that this thing works as I say it works, to the end stakeholder's perspective of this works as a stakeholder or a user would expect to use this functionality. So I wanted to just mention that this idea of the safety harness is very important. And when you think about functional testing, it sort of adds that nice collaborative layer on top of your safety harness. So you're involving the rest of the organization or the rest of your delivery team and your stakeholders in the idea of building the safety harness. It becomes a collaborative effort. We'll talk a little bit about that in a moment. So introducing specification by example. So this is a great book by Gochko Adzik, who also wrote about impact mapping and a few of my other favorite techniques. So I'm obviously not going to be able to do justice to this book in the short amount of time, but I want to mention it because I think it's really important to the overall discourse. So the idea of we have requirements typically in software development has to do something. But there's a very powerful understanding if you can shift your requirements to using examples. As human beings, if you don't understand a concept, right, what's one of the most common things we say? We'll say, oh, could you give me an example of that? Or could you show me an example of how that works? And when we start to think about software in terms of examples, some very powerful things happen. We start to understand a bit more about implicit requirements. They start to become more explicit because we start to, through the examples, understand what people mean. We also tend to, when we say give an example of a requirement, we can't sort of give an abstract, overarching, vague definition. We kind of have to say, okay, well, say you're here, right? When you do X, Y, Z, right, then certain things should happen. Right? And so the idea of the software and its requirements, instead of being requirements, being the summation of the examples that we can provide about how it works, kind of flips the idea of requirements gathering on its head. And rather than a top-down overarching process, what you have is a series of conversations and examples. And these are things we can ask questions about. These are things we can discuss and form a common opinion about. These are things that should hopefully, through their iterations, become very clear to us, because we as human beings understand the concept of examples way better than we understand the concept of abstract requirements that maybe have a lot of implicit understanding within them. And so this is a very important book in the discourse, and one that I think is something that a lot of these techniques that we're going to talk about build upon. And so the rest of this talk sort of assumes that we're going to be working in this specification by example format. So where do functional and acceptance tests, and I mentioned this is all about the joy of functional testing. So what is a functional test or an acceptance test? Like, what am I talking about when we talk about those kinds of automated tests? So if you haven't seen this before, it's from Brian Merrick, he's the original author there. What are we thinking about when we think about different kinds of tests? By the way, if you ever want to get famous, come up with a box that you can put four things in different quadrants. It works like a charm. No, Brian's amazing as a developer. But so what are we thinking about when we think about these different kinds of tests and how to categorize them? So we can think about on this axis here, we have the idea of tests that support programming versus tests that critique the product. So tests that support programming, on the left-hand side here, these are going to be more along the lines of this software works as I, the developer, think that it should work. Right. So if I've got a correct understanding of the requirements, then yes, this is what the software does. And following along this axis to the other side, tests to critique the product are more along the lines of from the outside in, right? Does this product do what I think it should do? Not just, do we build the thing right, but do we build the right thing? And so that's sort of where the one way they're divided. And on the other axis, you have here the idea of business-facing tests. Right, which are tests that human beings can understand and interact with, and typically, they're going to be more more easy to understand, or they'll probably use more common language like human readable sentences. or will be some kind of human interaction, like, for example, you see the idea of a showcase or a demo. And on the other side, on the other end of that spectrum, we have technology-facing tests. So these are going to be tests that, largely speaking, you've got to understand code to make sense of, right? You got to have some kind of background in technology, most likely, to be able to read and understand and process what these tests are doing. They're more face the coding side of things than the human side of things. So I've got functional and acceptance tests up here in the upper left-hand quadrant. And here, what I mean by those is these are tests that, largely speaking, and I will say they kind of start to bridge into tests that critique the product a little bit. So we may put them closer to this divide here. But the idea here is that functional and acceptance tests, and again, I'm using that term interchangeably. Functional testing, acceptance testing, it goes by many, many different names, but we're talking about high-level tests that use real components strung together to sort of verify that a requirement or a feature is working as intended. And so these tests support programming in that they're telling us that, yes, this application is working as we expect it to. It starts to bridge the gap, though, as we become more collaborative with our users, because we're also making sure that those examples reinforce that we are building the right thing, that we're building the thing that those users would actually want to use, that we're actually meeting those requirements. And they're business facing. And so these tests that we're going to look at tonight are using human readable sentences, right? We're not going to be, as much as I love, TDD and BDD, those concepts are not unrelated to this, but that is to say, we're actually going to go and automate real human readable sentences using SpecFlow this evening. And so puts it squarely in the category of business facing tests, right? Where human beings are going to be able to look at that, understand it, understand the examples, and provide feedback on it. So why is integration testing important? Why is it important to wire up, actual components and not have just, fakes and mocks? Well, you can see in some of these examples, which are, I always enjoy showing these, right? The paper towel dispenser and the blower are working correctly. The trash can's working correctly, but, when you put them together, not so much. Similarly, like we talk about unit tests versus integration tests. That lock was installed correctly, the door was correct, but we maybe forgot to check how they were integrated. This is one of my favorites. Someone measured out that sink probably, or just put it together, said, okay, it works as expected. Perhaps they did not turn the water on to test it. The sink is working well there, but you put them together, not so much. And of course, sometimes our code doesn't even do what we describe it to do. Right? Sometimes it's very difficult to have a documented code working as you would expect. And so this is always one of my favorites, of the exit points to the not an exit sign. So let's talk a little bit about Gherkin syntax. So what is Gherkin syntax? Well, if you're familiar with the framework Cucumber, I believe this term originates from Cucumber, which is a testing framework that sort of uses this methodology. So Cucumber, Gherkin's a kind of pickle, developers love puns and plays on words, great. So that's where you get the naming from. And of course, I'm paraphrasing that. I'm not a Gherkin historian, so I believe that's the origin there. But so what is Gherkin, and what is this Gherkin syntax that I keep mentioning? So we talked about examples earlier and the power of examples. So Gherkin is a great human readable, human understandable domain language for talking about examples. And it's on the surface, pretty simple. So the Gherkin syntax is essentially given, when, and then statements. You can also throw an and but, right, to those. So, given I am at the ATM when I enter, given I'm at the ATM and I've entered my debit card PIN, and I've entered a valid debit card PIN, when I click withdrawal, then I should receive money. Right. So the idea there is that when we talk about examples, right, we have this language, this given, when, then syntax. Now, if you've done unit testing before, or you've talked about unit testing principles and practices, these phrases may be familiar to you. You also might know them by a slightly different name, which is arrange, act, and assert. Right. So the given phrase here is sort of setting up the universe of the test. It's arranging the universe of the test and all the things that we need for that test to make sense. The when is equivalent to the action, right? We're going to perform one or more actions that sort of represent one logical action. And the then statement is equivalent to our assertion, right? We can say, hey, given certain things, when we take certain actions, then certain things should be true or false or equal to whatever. And so in that case, right, we have these three words become quite powerful and quite versatile, really, in terms of applying them to the examples of our software. So it's a little dark here, I know, on the stream, and I meant to actually update this to brighten it up. But so maybe, old syntax, you might have something like a system shall allow login access. Okay, that's great. Like we've all used, usernames and passwords before. We've all we probably have all set up some sort of a login system, whether we're just playing around or certainly we understand the concept. So what if we were to take that and kind of make it more of an example? And as a contrived example, right? But we'll talk about some of the things it gets for us. So maybe we say, okay, let's turn that into an example, right? We've got our requirement. We'll turn it into an example. We'll talk about it with the stakeholder. So given I am on the homepage, right? So as we're working with a web application of some kind, and I have clicked the login button, when I enter a valid username and I enter a valid password and I log in, then I should be redirected to my profile page. So what does this actually give us? Well, we know we're working with a web-based application now. We know that we have this idea of being able to navigate from page to page. We can see that there is a concept currently of a login button. And we see there's an option of valid data or valid passwords. So maybe we say, okay, well, what does that mean, right? What is a valid username or valid password? And so let's, we noodle on this for a little bit. And we take it to our stakeholder and they say, oh, that's interesting. When I thought about login, I thought about clicking on Google for my single sign-on, right? I don't care about usernames and passwords at all, right? And so now we've sort of brought this example into the realm of conversation with our stakeholders. We're able to use that to kind of say, hey, do you mean X, Y, Z? Right? And actually start to have a conversation about that rather than trying to adhere to these abstract high-level requirements. And also what we see here is there's the idea of, in our given statement, some setup. So if we say, for example, what is a valid username and a valid password? Perhaps they say, oh, well, we need to now set up something where this username and password is actually in our test system. So now we know that in order for that enter a valid username and enter a valid password, maybe we need to use real examples there. When I enter Sean Killeen and I enter, password 1234, which is totally not my real password, but say we enter that, right? And so now we kind of understand, okay, well, then we maybe need to add that to a system or a test system before we can actually test logging in with it. So it informs both the conversation we have about the functionality and some of the ways that we might implement this or go about automating it or even manually testing this feature. Right. So we understand, okay, if we want to verify this login path and we all agree maybe on the username and password scenario, well, now we kind of have an understanding of the exact steps we've got to take in order to verify this functionality. So similarly, that's a switch from dark to light there, isn't it? Similarly, if we think about the idea of a shopping cart, so one of the things I'll point out here is the idea of a book being added multiple times to a shopping basket. Right. So that the text you see up top here, the same book can be added multiple times, right? That's the idea. That's the scenario, right? That's the sort of general thing that we're testing. Some people might call this acceptance criteria, right? So maybe it's acceptance criteria, and an acceptance criteria can have several examples associated with it. It doesn't have to be only one-to-one. So in this case, we have given my shopping basket contains one copy of Harry Potter. Now note that we're saying Harry Potter. We're not saying a book. And this ends up being important in the later steps. When I add the book Harry Potter to my shopping basket, okay, so I've already got one copy of Harry Potter. I'm adding Harry Potter again. Then my shopping basket should contain 2 copies of Harry Potter, right? So this is great. This might lead to some further follow-up conversation around, okay, well, what do we mean when we say it should contain 2 copies of Harry Potter? Should it list Harry Potter twice? Should it have Harry Potter with a quantity of 2? Right? There are several things that we can glean from that in terms of conversation around functionality. Similarly, we know that we have to have a concept of a shopping basket. We have to be able to start our test with something inserted into that shopping basket. So now we have an idea of some of the data setup we might need in order to make the scenario work. If we had a blank database for our shopping cart system, I could spin up a blank database with the appropriate structure and create a shopping basket. If I've got a table of shopping baskets or order lines, and I could add an item to that order line. And so now we've got a spot where now I kind of have an understanding of the data setup required to execute these tests as well. So let's talk a little bit about the benefits before we jump in and see this in action. So right, this is a pretty common picture from around the internet. But the idea is our tests now consist of examples, right? Our examples describe our requirements, and the tests verify the fulfillment of the requirements. So we no longer worry about thinking about requirements as these abstract concepts. The fact that we are able to express them as examples and move to testing them means we have that much tighter feedback loop of our tests are going to be exercising our requirements directly in ways that all of the stakeholders understand. So we can start to do something like an automated acceptance testing, where maybe we have an acceptance criteria, right? And then we for our requirement, we start off with an automated acceptance test or an automated functional test in this Gherkin syntax, right? It's going to fail because we don't have code there to support it. And then after that, we start to do our TDD lifecycle if you're into that sort of thing. We build up our unit tests, and I am into that sort of thing. We build up unit tests and integration tests until such a time as that automated acceptance test passes. And once we've done that, we can be pretty darn sure that we're covered throughout the application, and we can move on to the next criteria. So one of the nice things about this is we mentioned human beings communicating in examples. That gives us consensus, right? At the time you begin the work, if you've already talked about the examples for the work, chances are a lot of those implicit requirements as you talk through those examples are going to be made explicit. You're going to start to come to a common understanding of what those steps are. And even more so, you're going to start to come to an understanding of how you're all going to test those steps, which is not to say that exploratory testing and so forth isn't still important. But the idea there is that you are going to now have a formalized understanding of, okay, to verify what we want, we're going to run through these steps. And if these examples work as we expect them to, the work is finished. And having that consensus at the start can be very powerful because it lets us shift things to the left. I don't know if you've heard this term, but usually it refers to moving things earlier in the process, earlier in the feedback loop, and making the feedback loops smaller. Remember that story or the example I gave earlier about getting all the way towards the end of a development cycle and then having a feature or a story returned because maybe we didn't agree on how we were going to test it, or we didn't agree on what the functionality actually meant. Well, if we have these examples and we're talking through them upfront, and we've got the consensus, well, there's a lot of clarity there in terms of what when something is done and when it is done correctly. So someone can walk through those steps and verify them, and now they have a nice understandable box in terms of how to verify the functionality that you've all agreed upon. And if something else does come up, you have some options at this point. It becomes very clear that it comes up because maybe you didn't think of that example, and you have a choice. You can either choose to add an additional example and automate that. Maybe the overhead's very low. Maybe it's a quick tweak. Or you can say, hey, we still have this example captured. Do we need to add it immediately, or can we add that in future work or follow-up work? But it takes a lot of the pressure and the stress off, I find, when you think about how to navigate those kind of situations, because you have consensus going in, you have a defined plan for testing things, and you have, as we'll see in a little bit, an automation structure that can prove that those things are working as well. So sign off becomes a lot easier. Sign off becomes something where we can say, okay, this is definitely done. I've got the automation. It's already stuff I've agreed to. I understand the examples. I understand they're being automated. So with a small bit of testing or a small bit of verification on a stakeholder's part, they may feel more comfortable signing off on some kind of feature or requirement. So missed requirements, as I mentioned. If they're missed, that becomes a lot more okay, because it might become very trivial to create an additional example to support them, or you've got the example captured, you're speaking in the language of example, so everyone's going to understand what's missed, and then you can decide how to deal with it accordingly and what the impact would be of that. But it gives us that toolbox, that language for understanding that a little bit better. So let's talk about SpecFlow. SpecFlow is the library, or a library in the .NET ecosystem, a really collection of several great tools that allow us to think about Gherkin syntax and map that Gherkin syntax into the test automation framework of your choice. So I'll show a kind of a really contrived example here. So let's take the idea of a vending machine. Now, there are a few typos on this slide. I've actually meant to correct it, and I need to do so. But we'll see if we can find them all together. I remember it from the last time I did this. So given there is no money in the machine, might call, right, this is our Gherkin sentence on the left. SpecFlow is this sort of glue in the middle that is mapping that Gherkin sentence to some piece of code that our automation is going to execute. So we say, given there's no money in the machine, and SpecFlow knows to map that to the release change method, which sets change equal to 0. When I insert a coin, maybe calls the insert coin method, probably without a space in it. And maybe that inserts, 25 cents or increases the balance by 25. And then we can say, then the balance should be 25 cents. And the SpecFlow as the Gherkin or acceptance test runner maps that to the assert machine has quarters, which maps to an assertion that you might see in a unit testing framework. So what SpecFlow is doing behind the scenes is it's generating an N unit or an X unit test, and it's actually executing that test when you execute your SpecFlow test. And so it's really a really great way to kind of map to your existing test automation structures and get some additional benefit. But enough about me talking about it. Let's go ahead and dive in and think about some examples. So I'm going to go ahead and switch to my other screen here for sharing. But while we do that, I haven't seen the chat so much yet, but let me know if there are any questions so far, or if you've got anything you'd like to note or discuss while I'm pulling the other screen up. Alrighty.
All's quiet.
That's terrifying, Kevin.
Hey, you know how virtual stuff goes. It's everyone's just watching and waiting.
Quite all right. All right, I'm gonna go ahead.
Can you parameterize with Gherkin?
Yes, you can, and we'll show an example of that during this talk, actually. So yes, absolutely. Awesome. It's a great question. So let me go ahead. I thought I was sharing my screen, but I realized I may not be. There we are. We can see a Visual Studio window. All right. So yes. Yep. Great, thank you, Kevin. So what we have here is I'm going to talk through a few examples, a few demos here. So what we have, first I'll demonstrate setting up SpecFlow from scratch and kind of writing a quick straightforward SpecFlow Gherkin sentence test here. And then I've got some other demos here where I'll show you a few other features, and we'll wrap up with an example of another SpecFlow ecosystem product, which is SpecFlow Plus live documentation or living documentation. So we'll talk about how that can help us. All right, and so first up, I've got in my solution here, I've got a project I'm calling from scratch. So a couple of things to note here is SpecFlow is an extension for Visual Studio that you can install. It's free to install, and the extension gives us some highlighting and some other some great features in terms of being able to create feature files. So we can see here I've got SpecFlow for Visual Studio 2019 installed. And so next up, we're going to have to add some NuGet packages, right, to make this work. So I'll go ahead and just handy dandy NuGet Explorer window here. So I'm going to install SpecFlow into my from scratch project. We'll install SpecFlow.NUnits. And by the way, it works with NUnit, XUnit. I think it works with MS Test potentially. I could be wrong about that. Definitely works with NUnit and XUnit, whatever flavor you prefer. We're going to use NUnit in this example. So I'm going to go ahead and look where I'd like to install that. We're going to go ahead and install SpecFlow.NUnit here. I will accept the various agreements. Thank you. I see the comment in the chat that it does indeed work with MS Test, which is great. Okay, so we've got those packages installed. We're also going to install SpecFlow MS build. We're going to install SpecFlow tools.msbuild.generation. And what that's doing is that's actually, I mentioned that SpecFlow sort of creates unit tests for you in your framework of choice behind the scenes. And this is one of the hooks that allows it to do that. When you build your project, it's actually generating unit test files behind the scenes. And we'll take a look at one of those files and what it looks like. You typically don't have to look at those files once they're created. So we'll also, just for the sake of this, we'll go ahead and install the NUnit 3 test adapter. So show our tools off a little bit here. Oh, I'm going to install a beta of NUnit. We'll see how that goes. All right. So the other piece here that I've got is I'm going to enable a tool, a great tool that I love to use called nCrunch. I am a happy paying user of nCrunch. If you do any work with automated testing, I highly recommend it. What nCrunch does is it runs all of your tests behind the scenes, and you can scope it to just the tests that have changed and things along those lines. And so we'll see some of the feedback from nCrunch as part of this talk. And I just really enjoy it. It makes me really productive. I see that Lee is a fan of nCrunch as well. So let's go ahead and check that out. We'll look at our nCrunch test. It should be initializing. Right now it's building my project and we see hopefully tests are passing. Okay, so I've got some passing tests for my other projects. So it looks like we are at this point good to go. So let's go ahead and create a feature file with SpecFlow. So I'm going to go ahead and go to my add dialog here. I'm going to go to a new item. All right. Okay, we're going to go to the SpecFlow dialog box here. I'm going to create a SpecFlow feature file, and we're going to do the basic out of the box demo for this one. We're going to do a calculator. We're going to call it the feature is going to be called addition, and this just coincides. In fact, it surprised me by the last few times I did this. And actually, this is the out of the box example now for SpecFlow, so coincides quite nicely. So right here we see a feature called addition. Now, of course. You can note this can be just a description of the story if you want, but a lot of folks, if you're doing a feature, sometimes prefer the, as a, I want, so that, or something along these lines, right? So I would probably say, as a numerically challenged person, which I certainly am at many points, I want to computationally add two numbers so that I make less mistakes, right? So we'll kind of rephrase that, right? We'll get the value proposition there. So now I can quickly see that. So what we can see here is a couple of things. Notice I get some syntax highlighting, right? This is SpecFlow, the extension, doing some great work for us. So we've got, the feature is highlighted, the scenario is highlighted, our given and when then statements are highlighted there. And we also see this concept of a tag. We're not going to go into the concept of tags today. I'm going to delete it, but tags you can think of as great ways for grouping and understanding and tagging your various tests in different ways. And it's a really powerful feature of SpecFlow. We're just not going to go into it this evening. But as you explore SpecFlow, I hope you'll check that out. So the second thing we might notice is we've got our phrase here. Now we have some text in purple. Now, if I was to try to, what I'll do is I'll hit F12, which I might do to go to code or to go to the spot in a test where this code is. And SpecFlow actually helps us out a bit. When I hit F12, I say, okay, what's this purple code? I go to F12, and SpecFlow actually pops up some text that says, there's no matching step binding found for the step. Do you want to copy the skeleton to the clipboard? Well, that sounds delightful. I would absolutely love to do that, SpecFlow. Thank you. And so I'm going to go ahead here and let's go. I have an addition feature. I'm going to rename my class 1 file here to addition steps. Just kind of keep it in line with the feature here. I should rename the file itself there. All right. I'll go ahead and we'll remove our examples there. We'll paste in what we have. Now we can see here, I have to, I'm prompted to add the reference here to techtalk.specflow, and we can see, what do we see here? But we see a phrase, an attribute here, a given attribute, and it matches to a phrase. The first number is, and then we've got some nice regex in here. SpecFlow knows how to parse what's in there, and we tell it that we want an integer. So what we'll see when I save this, we should see the addition feature. I think it might take a second, but I think we'll see the highlighting will change here. It might just take it a second until I actually implement it. All right. And so what I'll do here is, in this case, I'll just say, I'll add a little bit more. Oh, I realize that's why it's not showing up. When I have a steps file, one important thing that you need to add is you need to make it sort of visible to SpecFlow. We do this by adding the binding attribute. Now it makes these addition steps available to our the Gherkin syntax to use. So now if we see that nCrunch is telling us our test is failing, which is great. So we see now the highlighting has changed. I see the first number is, and I see it's sort of parameterized here as 50. So, I could explicitly say 50 and map that to a string, but we've got some parameterization happening right out of the gate here. So let's go ahead and I'll rename P0 to first number. And let's, for the sake of this, right, I'll have a backing field here. So we'll say private int, first number, and then we'll say, first number equals first number. Okay, let's go through that process now for the second number as well. We'll copy that boilerplate. Thank you, SpecFlow. And see it's another given statement. Anything with an and under it will be mapped to the word before it. So we see and, which makes this part of the given phrase. So we still have a given step there. Given the second number is, and then so we'll do this similarly. We'll call it second number. Go ahead and we'll say private int second number. Similarly, we will say. By the way, what we're doing, we're removing the scenario context.current.pending. If we were to copy all the boilerplate and then run that test, we would see that those steps are pending, and therefore the test would be in an inconclusive state. So when the two numbers are added, okay, now I've got this interesting idea here of the two numbers being added, right? So I'm going to leave that pending because we don't have any production code here to do anything to add those numbers yet. And then I'll copy the last phrase as well here, but we are going to have the idea of a result. So I will go ahead and we'll have some kind of result from this operation, right? So we don't know what's going to happen here in the when the two numbers are added, but we do know that we're going to have a result, and the result should be, and I'll call this expected result. And then so I will go ahead and I'll add my end unit style assertion just because we're using the out of the box. We'll assert that the result is equal to the expected result. All right, so we've got a scenario in place here, and now we can see this whole right. Our scenario is completely mapped, and we see nCrunch is running, and we see there's none of those tests are passing. If I go to my tests here in nCrunch, one of the nice things, I'll throw this up on the screen so it's maybe a little more visible. One of the nice things we have here, I'll comment it out here. We see here that in the actual output of our tests, we can see that we're actually showing which steps are being run and how long they take. And so we can see that this step here, for example, when the two numbers are added, we see it wasn't done, it's pending. And so that it sort of shows up as an error in our case. So nCrunch says this test reported an inconclusive result, which is exactly what we would expect in this case. So let's go ahead and implement something real quick. Let's, this might normally be in a different project in a different file. So I'm just going to put it here for example's sake. But you can certainly reference other projects in your production code as you should. So we'll, create a public class called calculator. We'll do a public int method called add, int first number, int second number. Right, and we want our test to fail first, right? We're still going to go for that red-green refactor here, right? So we'll just have it return 0 for starters. And so maybe we have this idea of a calculator, right? So we have a private calculator. Now this is where you can call it. You call your code class under test. I tend to use SUT as an abbreviation, or situation under test. It's however you want to do it. You can call it calculator. And a lot of different takes on how to name that. So what I'll do is I want to do something before all my tests are run, right? So before each scenario, we'll do public void, right? Before scenario, I want to initialize my calculator. So I'll just go ahead and say set equals new calculator. All right, so I'm sort of giving us a fresh calculator class at the start of each test. And now what we should do here is we should go ahead and say when the two numbers are added, right, we're going to set our result equal to calculator dot, probably should make that public class add. Okay. Oh, sorry, I have to use set, not the class. Dot add first number and second number, right? And so we'll go ahead and remove that. We should see the test fail for a different reason, right? The steps are being executed, but rather than 120, right, we see 0. By the way, there's a great comment in the chat. Yep, it could be subject under test, could be system under test. I tend to say situation under test. This is how my brain tends to think about it, but also valid examples in the chat. So we see here that now our feature is failing as we expect it to fail because I'm actually not returning the right results. So I'm going to go ahead and get rid of these comments. And then let's go ahead and make it do what it should do. So let's say return first number plus second number. All right. So we should here, and Crunch is running our tests again in the background. We see they are now green. So we have automated our first feature, right? We've added two numbers together. So I've got a couple things I can do here, right? I can make these examples, and I can parameterize them, which will show. But for now, I want to show one other feature of SpecFlow, which is this really nice auto completion, a really nice sort of IntelliSense when you're working with your features. So, for example, if I wanted to do another scenario, maybe I want to add a positive and negative numbers. Right. So we see in the scenario, I had some autocomplete when I started typing the SCE, so I could sort of tab into that. But now I could start to say, okay, given, we see that I've got some tabbing there. I can say given, if I hit space, I can actually go and see some of the steps that I've previously mapped to my given phrase. So I could say, instead of saying the first number is 50, I could say the first number is first number, right? I can go ahead and put what I want in there. So let's say -10. And the second number is, I can tab into that. Second number is 25. When I'm still going to use the two numbers are added, then the result should be 15, right? And I should go ahead and have that test pass there. And it does, right? So one of the things I want to point out, though, is how much faster it was to add that second example to the first example. Right, we've already done a lot of the steps in binding, and we've already gotten the benefit of some of that mapping that we've done in the course of taking these steps. So, coming up with another example or working through an additional example is oftentimes much faster the second time around. And so, one of the things that folks say here is often a question at this point to get to the question about parameterization. So, at this point, there's a question of, okay, well, we could parameterize some things, but would these two scenarios make sense to parameterize them and sort of lump them in together? And since we have the idea of adding two positive numbers, and we have the idea of adding to a positive and a negative number, I would argue we might want to keep these as separate scenarios or separate examples. But say we wanted some additional examples of adding positive numbers together, right? So maybe instead of a scenario, we use the idea of a scenario outline. So a scenario outline in SpecFlow lets us do something along these lines. So I can say instead, first number, second number, expected result. I should be able to here say first number, second number, expected result. And say, similarly, we had 70 was our first example, and 50 is our second example. Now we can see I'm getting the syntax highlighting. I'm getting some headers there for that. And so I should, I think, see that if I'm parameterizing them correctly. Perhaps I am not. Let me just double check my syntax. It's been a second since I've work with the scenario outlines. So we're actually going to go to our friend Google because I'm not ashamed to Google my stuff here. So let's see. SpecFlow scenario outline. SpecFlow scenario. So it should be the angle brackets, I think. Let's go back to that. Understand what's happening here. Scenario outline contains examples, of course. By the way, this is we might as well use this time to talk about how the SpecFlow documentation is pretty fantastic. And they have a great blog series on how to phrase your given whens and thens. And so I think that that's something that's worth pointing out as well. So scenario outline, let's see. Given there are, right, first number, second number, right? We have brackets and we have the examples, start left. Okay, so interestingly enough, what I would expect to see in this case, and what I'm not seeing, would be multiple test cases generated. So let's go ahead and just let me add one more and see if this is maybe because we only had one example here. So I can see here that in this case, it doesn't look like nCrunch is running our test. What I'm going to do here is see if my other test runner will run the test just to double check. Live times here, folks. So we'll see if our other test runner does it. And while we're doing that, while I'm running those test scenarios here in my other unexpected, see, check the test output pane. Let's see, test discovery. Interesting. So there's some issues there where we're unable to find. I think I understand the issue here. I think there's a test reference that's missing here. Microsoft.net.test.sdk potentially is missing. I'm just going to double check that here. Microsoft.net.test.sdk. Let's go ahead here and install that in our project. I think that might be what's hindering the test discovery. And if not, then we'll move on. But we'll double check that at least. Okay, so let's go ahead, rebuild here. See if we pick up on those tests. And if not, then we'll move on. So it looks like we may still be hitting an issue here, which is okay. So, but anyway, this is how I would expect this to work. And so, you know, it's funny, yeah. So you never know that what's going to happen with a demo here. But what I will commit to you is I will figure out what's going on here, and I'll let the group know in the meetup chat just to see what was happening here. So we do have the understanding here of Test Explorer, and we do see here our from scratch here. It looks like some of these tests aren't running. We see that they are here. I am unclear why they're not running. So okay, we'll have to look into that. So either way, that when you have the scenario outline, this is how I would expect it to work and how I would expect it to work in the future. Those tests would both pass. So just for the sake of making sure we've got some passing tests here, right? I'll go back. We'll get back to a spot where these tests are passing. All right, so our test passing again, even though we may have taken a slight step backward, we're going to go ahead and talk about some of the other features of SpecFlow. Yeah, I agree, Lee. It's weird that they're being sent in as strings because I would expect the example scenario to work, and it does map them explicitly to integers. So we'll see. But I'm going to figure out what's going on there with the tooling, and I'll get back to folks. So to move on for the next demo, I've got some other demos here. So one of the things I want to mention is that we also in the let's first show what's happening behind the scenes. So I mentioned that SpecFlow behind the scenes is generating tests with your testing framework of choice, whether that's NUnit or XUnit. In this addition feature, we can see that if I expand that here, there's a sort of a code behind here, right, or a dependency file here for addition.feature.cs. So SpecFlow, when we build, is actually generating this file behind the scenes, right? So it's designer generated file. So if you were to scroll through here, you'll see some attributes that you might see during your normal course of testing, right? So a test fixture, right? The idea of a description here. It's generating some one-time setup and some one-time teardown for us, where it's doing some of its own functionality behind the scenes. But so it's basically code generating some NUnit tests that look a little funky behind the scenes, but they're what allow SpecFlow to execute that mapping of that Gherkin syntax into the automation that we're describing, and to do that using our unit test framework of choice. And so we see here, for example, behind the scenes, it's generating test case attributes here. I don't think I rebuilt that here, so this may change in a little bit once I rebuild. So we can see here, for example, that those test cases went away, right? I rebuilt, and so we've got those, the test cases went away because I'm no longer using that scenario outline for the example. So also, in terms of debugging stuff, this is what I'm going to do later, right? I'm going to go look at that example, that scenario outline. I'm going to come and see what the heck did it generate behind the scenes here, and did it generate something wrong, or was I doing something unexpectedly? And we'll get you the end result. Willing to bet it's my fault. As it typically tends to be. So this is what's going on behind the scenes in addition in our feature file. So let's look at some other features here. So let's look at, for example, we'll look at the list products feature. This is using a very contrived example of the idea of like a vending machine or something along those lines, right? So we have a slightly blunt statement of value here in terms of not being clueless, but here we see we're using a table for examples, right? So given I have the following products, right, and we're defining the name of our product and its cost. One of the nice things that you can do here with SpecFlow is it actually has the concept of a table built right into it, much as Gherkin, this Gherkin syntax does. So if we look at our list product steps here, we actually can see, given I have the following products, SpecFlow has a table object that I can actually pass into this test. And what we can do then is we can map that information that's coming in that table to an actual object of our choice. Now, in this case, I have a product object, which is just a plain old CLR object with a name property and a price property. And so what's happening behind the scenes is SpecFlow is passing in that table construct, and I'm calling its very nice tooling to go ahead and map that to this product object and set it to a list of products. So whatever we pass in there, it winds up as a list of type product here in our products variable. So that's one way that we can use a table. We saw another way that you could potentially use a table with examples. And so we can do a few different things there, but there are various ways to apply tables and to map them in different ways that you'd like. So I wanted to point out here that this is possible to do this with this sort of object mapping. And so we are able to say that the product should include X, Y, Z. And so let's just look at this overall product here, or this overall feature. So given I have the following products, I've got Pepsi and it costs $2, and they've got Mountain Dew and it costs $2.50, and I'm at the vending machine with the products. When I get the current products, then the product should include Pepsi, and the product should include Mountain Dew, and the product should not include Coke. So if I go to the steps here, given I have the following products, we're mapping to that list of products. When I'm at the vending machine with the products, right, it's a little contrived, right? But we could say, oh, it's implied that you're working with the vending machine, but we can be explicit about it as well. And so here we set, the vending machine into equal to a new instance of a vending machine. Remember earlier in our test, I could also choose to do that in like a before step before everything starts if we wanted to do it that way. But since we needed to define the list of products first before passing them into the vending machine, it makes sense to do that in this step, in an explicit step. When I get the current products, we say, okay, the current products variable is equal to a call in our vending machine to get current products. Then the product should include, right? And I've got some link here that takes that product name that's mapped and that makes sure that the list of products actually contains that. Now, again, our asserts here are pretty, I think there's probably a slightly more elegant way we can write that, but we're being very explicit here in our intentions. We say the product should not include. Similarly, we make sure that no products are contained in this, that the string is not contained in any of the product names here. Right, so that's so that we have the ability to map to a table, to take that data in, to operate on that some more. And I know I'm running a little longer. I want to get to some questions and discussions. And so one of the last things I want to show real quick. Well, first, a brief note. One thing I'm not showing tonight, as an explicit choice on my part, is the automation of a web browser using Selenium. Why is that? SpecFlow and Gherkin-based tools are very often used to automate, to use a tool like Selenium, which is a tool for web browser automation, to pop open a Chrome window or a Firefox window and navigate around. And that's actually great. I have nothing against that. And with SpecFlow, there are fantastic examples on how to get started doing that, and it's definitely doable. I'm not doing it here specifically because I want to show folks that it's possible to do these kinds of tests without doing Selenium automation. Perhaps you can write these tests but interact with your application at the API level, or by wiring up some production, some objects and using real dependencies, and maybe not having to go quite that high. And the reason that we care about that is the idea of, some call it the testing funnel, some call it the testing pyramid, but there's an understanding that when you're running UI style tests, right, with a web browser, they're going to be more brittle, they're going to break more often. When they break, they're oftentimes going to be not because your actual functionality is broken, because maybe you change a variable name. And even though everything works as expected, your test is looking for a certain variable name or element ID, and therefore it fails. The tests take a lot longer to run. Typically speaking, we have at a project I was on, we had, I think it was 35,000 or at least 20,000 unit tests, and they ran in 6 minutes or something like that. We had about 200 UI level tests, and they took hours. Right, so there's a big gap in terms of the amount of time these things take to set up and run. Because you have real dependencies. If you're working with a web browser, well, it's got to be served from somewhere, and maybe you can do that on your build server, but there are additional complexities involved. And so my case is not to say that that's bad. It's to say that typically, if you have no test coverage at all, that's a phenomenal place to start, because then you can build up your lower level test coverage. If you already have a lot of test coverage in a given area, adding UI level tests might not make the most sense, because the trade-off there might be worse than you're going to get for it in terms of the runtime and the maintainability and the other considerations there. So I wanted to add that just as a practical note to sort of bookend this discussion. It's doable with SpecFlow. It is absolutely possible. I may even add an example to this in the future of doing something along those lines. But I wanted to say, just philosophically speaking, we want to make sure we're at least doing those kind of tests consciously, and we're not defaulting to a UI only level of tests. So just my understanding currently. And again, your mileage is going to vary. Your situation might be a little different. So next up, what we have here is the idea of so we've got these Gherkin syntax files. This is great. We've collaborated with our users. We've come up with these examples. We're automating them. That's awesome. So the only problem is how do our users check up, or our stakeholders check up and look at all the examples we've generated, and maybe get ideas for new examples, or talk with us about maybe where there might be some missing examples that we can work on, or really get proof that our tests are actually running these examples, and they are being run successfully. So SpecFlow, and there are other tools out there to do this. There's a tool called Pickles, which is an open source tool for this. And SpecFlow recently made their SpecFlow Plus suite free for everybody. It was previously a commercial project. So we're going to look at the SpecFlow Living Doc generator here to do that. Now, the Living Doc generator can be installed as a .NET CLI tool. And so what we'll see here, what I'm going to show you, is we'll go ahead and we'll execute that tool. And that's actually going to generate an HTML file for us of these specifications that we can publish somewhere and have our users look at. So let's go ahead and pop up a PowerShell window here. I'm going to go ahead and get to my repository directory, which is where I thought I was already. Okay. Okay, so I've got I'm in the directory of my solution here. I have previously installed, in fact, let me go to the reference here. I have previously installed SpecFlow's Living Doc generator via running the .NET tool install command here. And there's great docs on how to get started with it and everything. So I've previously run that step. So now I'm going to go ahead and I'm going to go ahead and run we're going to call it Living Doc feature folder is the name of the command. And I'm going to specify the folder as just my current folder. So let's go ahead and we'll call that. We can see here that it's working on an HTML file here. And let's go ahead and see the output of that. Let's go ahead and open. One moment here. I know it's not visible to you at this moment, so I'm actually going to go ahead and share my entire screen real quick. 1 second. Okay, so now should be sharing my entire screen. So let's go ahead and look at that again here. So I ran the Living Doc feature dash folder period script here, and then we can see here that it generated an HTML file. So I'm going to go ahead here and go into my directory here, and let's just open up that HTML file and see what it looks like. So what we can see here is a really nice hierarchy. We have a list over here of exactly how this is working. I see the scenarios here, scenario outline. I see that we have the examples here. I can filter down to individuals or at any level. I can look at feature titles and scenario titles if I want, or if we have many tests, I can filter them. We can see here the tables get nice formatting. And one of the nice things we have here is we also have an analytics tab over here. One of the nice parts about the analytics tab is that we can actually hook this up. And now I'm not doing it here, but if we have our CI/CD system running these tests, as hopefully we would, we can actually hook that into this results document generator as well. And we can map what features are running, how many of them are passing, nice summary charts and some great little analytics for different steps and how often they're being run and how often those things are happening. And so I wanted to point that out because I think it's a really nice feature, and it's a nice clean way you can provide this HTML publish it alongside your build, and you can actually have your users, your stakeholders be able to come look, browse the examples, see which ones passed and failed, and maybe get some ideas for giving you additional feedback or for coming up with additional examples. And I want to end tonight, before we get to the discussions, just with a quick story about how this played out at a client I was working with. So I was working with a client that had modernized a mainframe to a web application. And over the course of that project, which was a multi-year effort, over the course of that project, what happened was, one of the big complex pieces of any one of these sort of retirement systems is the idea of participation and who's eligible for benefits and how does that work. And over time, right, between requirements archaeology of a 20-year-old system, stakeholders who some had retired from the organization, right, different changes had been made. Some folks had different ideas about how functionality should work. There are certain parts of this engine over time became a bit complex. And to be honest, our automated test coverage was way worse than we wanted it to be in that area. And even if we had unit test coverage of some pieces, the end result of what should this functionality actually really be doing in all of these complex examples, the system wasn't really accurately capturing that. And what we started to do was to talk to our stakeholders and to kind of test the waters a little bit. When we talk about how something should work, we'd start repeating it back to them. So in the form of an example. All right, so say, all right, given someone is of a certain age, of maybe a certain company with this kind of plan, when they are enrolled on this certain date and they're under a certain age, then they should belong in these groups, right? And we started confirming things that way, but also we're starting to build this test vocabulary. And then we started to dip our toe in the water by showing that we could automate those examples. So we had a test environment we could create the data for. We had an empty database with a schema that we could work with. And so we worked with our stakeholders to get that and procure that. So we started adding test data to that to bolster these examples, and started being able to show that we were automating them. And very quickly, what we found is stakeholders would often say, well, what about this? Well, what about that? And we got to say, great, that's awesome. We can definitely automate that. Well, what about this? And slowly but surely, and we had to modernize this system to meet a new product requirement for a different kind of retirement plan. So a very core change to the system. And so we started melding this experimentation with that need. We said, hey, we want to make this change. We don't want it to be risky. Let's start to get more of these examples together about how this works. And as we do more and more of them, we'll have the steps that'll get faster and faster. And the users seem to really enjoy, maybe not enjoy, it's maybe the wrong word, but they really respected that feedback loop. And what we saw is that folks kept offering more and more examples, and we were empowered to create more and more examples. And by the time we were done, we had over 3,000, I believe it was, Gherkin style tests for this functionality, and probably some of the slightly other pieces of functionality as well. But what happened as a result of that, right, is we had a large sort of UAT or acceptance testing period slated for this feature. And we were able to drastically reduce the risk of that testing period and the time of that testing period, because we were able to show that these examples were covered, and the end users or the stakeholders who were going to be testing these results were the ones who'd given us the examples in the first place. We were already using all the examples they could possibly think of. And so as they came up with new examples, we could quickly accommodate them and add them. And so what happened is that gave the project a great deal of confidence to be able to move forward, and really sold me on the idea of these tools and using specification by example as a collaborative mechanism to get to that great spot with stakeholders, where you can start to turn around functionality in ways that they understand and start to speak the language of examples and speak in terms within their domain. And so that was a sort of a success story that I wanted to leave you with, because I think that everyone here at this talk, or really at this group in general, you're probably people who care about doing things well. You care about process, you care about delivering for the people you're writing your software for. And if you care enough to collaborate and invest and explore in techniques like this, you have the potential to shift the trajectory of your projects and your products, because you are able to start to become more collaborative, to think about these things up front, to shift those things to the left, to make those feedback loops smaller. And it's amazing what a difference that can make, what an impact that can make when you add up the sum of those changes over time. It doesn't all have to happen at once. Like any testing effort, it doesn't have to be done as one big batch of let's stop delivering and create tests, right? That doesn't necessarily work. But what we can do is start to apply this technique for our benefit in closing those loops. And so I hope that you'll consider that as you go forward and think about creating tests that have the benefit of being understandable and collaborative for your users and stakeholders. And so with that, what I'm going to do here is I want to turn it back over. I saw some chat happening. I didn't actually see the questions go by yet. So I figured, Kev, I don't know if you want to moderate if there's a bunch of stuff, or we can start to take it one by one. Kevin and Drew.
Let's see. We can kind of take it one by one.
All right.
Actually, I'm not even sure if it's questions. It's just more conversation.
I assume it may be heckling.
Yeah. Let's see. I had to step away for a minute earlier, so I'm not sure. Did you answer anything along the way?
You can say you were sleeping, Kevin. It's fine.
Well, no, I got called into the other room, so I had to escape.
No, I'm looking. I think I did answer a few as we went. Let's see. Do you keep the generated unit test files from source? Okay, I think I'm caught up now. I can probably moderate it. So, do you keep the generated unit test files such as feature.cs from source control or exclude them? So we are checking those into source control in our case. And that was because we wanted to just see if there were any diffs along the files as well. I've also seen folks exclude them. So I think it kind of works either way. If you've got a CI/CD system in place, then what's happening is that build process is generating those tests behind the scenes anyway. So you could theoretically safely delete them, right? You also can commit them if you want to understand the output. Since it's designer, if I was starting a project now, I would probably exclude those .feature.cs files from source control, because I want my tooling to generate them consistently. And because personally, in terms of what's generated behind the scenes, I'm not going to get as much value from a diff of those files as, because I'm not really reading that behind the scenes to begin with. So if I was starting a project now, I've seen it done both ways, but I would probably myself exclude those files as they're auto-generated. If they weren't being generated by the build process itself, then I might feel a little bit differently about that. Another good question here. Is there a way to represent hierarchical data with a table? Seems to work better for flat data. This is a good question that gets to some of the philosophy of the Gherkin syntax. When you think about expressing hierarchical data, like for example, I'll just say, given I'm recently a dad, and so I'm thinking in terms of parent and child stuff all the time. But let's say, given we have a parent and two kids. Maybe we have a hierarchy or an object there. So we could say, we could try to represent that hierarchically as a table, right? To say, given I have, this structure, right? But what we might want to do is start to think about that in terms of the human understandable sentence structure. So what I might want to say instead is, given I have a parent named Sean, and that parent has a child named Eamon and a child named John. Right. What we've done is we've sort of made it more specific about how that's working, or we could say, given that parent has two children, and we could put those two children into a table if we wanted to do that. And then in your actual steps, as you're mapping that to your binding, right, your code there that's executing can do whatever it needs to do. So if you define a parent, it calls the step where you define the parent. And then if you add the children, you can map that to constructing an object structure however you want behind the scenes. But I think one of the things that's important to do there is to kind of call out that concept and separate it, rather than trying to represent an entire structure of data in that way. So this is a short way of saying I don't believe it supports it, but I also don't know that I would use that structure if it was available to me, because I think there's a value there in splitting that up. Okay, and then so similarly, that conversation there, normally the table represents a specific part of the hierarchy. Yep, I think that maps pretty much to my understanding. Okay, so I'm looking at the chat here just to see what else we've got. I think I think that's it for the end of the questions that I can see. So what I'll do is we can certainly, leave this open for a bit for a couple more questions. But I want to just end by saying, check out SpecFlow. It's open source. It's now free. Even the tools that were previously commercial are free. Great suite of tools for doing this kind of work. And I mentioned their blog. They have a fantastic blog series about how to format these Gherkin syntax and how to be thinking about mapping these things and modeling this experience. And so there's, a lot of great stuff out there for this. And I hope you'll take that away and see if we can put this into action. And if you do, I'd love to hear from you. Let me know if you're hitting roadblocks. Let me know if you're hitting problems. This talk is pretty much an excerpt of like a 3-day long course I used to teach. And so really, we want to make sure that, there's a lot more content here than what I'm giving you tonight. And I'm certainly, I've got opinions to spare if you want them. So feel free to hit me up. Oh, we see someone asked if SpecFlow could work in Rider on Mac OS. Also interested about code. That's a great question. My understanding is that if you were to open those tests, you should be able to run them because they are, again, generating NUnit tests behind the scenes. I believe that what you would be missing out on, and this is just my guess, I have not done it, is the SpecFlow extension and what that offers in the terms of creating a new feature file and getting that syntax highlighting and some of that nice stuff that you might see in the feature file. So that is my understanding at least, but I'm going to go ahead and try to confirm that. So I've got 2 items to confirm. One is the ability of SpecFlow to work in Rider on Mac OS X, and the other is to figure out what the heck went on with that scenario outline. So that's my homework for you all tonight. All right, so we can open it up, and certainly if anybody else has more questions, but otherwise that's it for me for tonight. I'll put up my information in case folks want to get in touch.
Well, we appreciate it very much. And yeah, folks, now's your chance. If you have any last minute questions for Sean, drop them into the chat.
And could be questions, could be comments, right? Certainly, there's a lot of different opinions in the testing space. So if you're not feeling too sure about this technique, or you're kind of thinking about downsides or other things, I'm also happy to hear some feedback there.
All right, friends.
All right.
Well, I think we're good, Sean. Thank you again. Thank you, everyone, for hanging out. We've had a pretty good sized crowd tonight, so it's
great.
Always good when you have double-digit viewers. That's always good. Thanks to the folks who followed during the session. We also had a raid while you were talking from Chef Brent, or Heck Brent. Brent's up in Philly. Good guy, works for Twilio. So I appreciate everyone that came over from Brent's channel. But yeah, I think we're good. Drew, do you recall off the top of your head who we have next month?
We do not have anyone currently scheduled.
Oh my gosh. So Drew's going to show off his new fancy clock that he's building.
That is a lightning talk at most.
Yeah, we can do lightning talk. That's fine.
General, I'll do another shameless plug for the .NET Foundation. The .NET Foundation, if you're looking for speakers, actually recently launched a speaker directory. So if you're looking for speakers on topics around .NET, you actually can go, or you can Google, .NET Foundation speaker directory, and there's a great list there of folks all over the country with different topics.
Now, so I know I'm in that list, and I have actively sent messages to people in that list and have been ignored. So, the best part about a directory is when you're ignored when you contact someone in it.
It's like cold calling someone in the phone book, right?
Yeah. Like, hey, I saw you're on this list. I would love to have you at the user group. Pick a day. Ignored. So,
well, there's plenty of other speaking fish in the sea, Kevin.
There are, yeah. But all righty. Well, actually, I'm going to stop the recording. So thank you, Sean, for joining us. Thank you for everyone who attended today.
Thanks, everyone, for having me.